Relations and functions. What is a relation? Relation is mapping between two sets. Two sets. So this is set A. So this is set B. Right? Let's say set A includes 1, 2, 3, 4. Set B includes 2, 4, 6, 8. Right? Now this the connection between members of, right, the member 1 of set A is connected to member B. So that's a relation, right? This relation also you can, R, the letter capital R indicates the relations. So 1 is related to 2, you can write like that, 1 related to 2 like that. So differently. Suppose 2 is connected to 2, then you can say 2 connected to 2. 2 are 2. This means 2 is related to 2. 3 is related to 6. 4 is related to 8, like that. Right? This the set A is known as, set A is known as domain. Domain. Domain of the relation. So this is codomain. 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 Right? B is known as any set. But for this mapping, only now you know 3 is related to 6. 4 is related to 8. Okay? 4 is related to 8. Now 4 is not used. This 4 not used. Okay? Is it clear? Hello? Then what is range of range of this range? Range is actually 2, 6, 8. Right? 2, 6, 8. But range is subset of B, codomain. Okay? Range is subset of B. Right? What is codomain? So this is codomain. B. Set B is codomain. Okay? So this is subset symbol. Subset. So sometimes you can use like this also. Not necessary. Equal sign. Both are equal. This and this equal to this. These two are subset of notation. Now 2, 6, 8. This range is subset of B. There is subset, right? How is this relation? Why we call this relation? Right? We call it relation. Relation can be presented in different way, right? So relation, this is the one method, right? So you can this relation can be presented in this form. 1 is connected to 2, 2 is connected to 2, 3 is connected to 6, 4 is connected to 3. There's another way to represent this relation. So you can represent the relation like this: 1, 2, 2, 2, 3, 6, right? 4, 8. So this relation you can, the R you can take a set. So you can represent this relation as a set of two tuples. Is it clear? Same relation you can present in different way. Different way. Okay. Right? Same relation. Now for this relation, so actually what is Cartesian product of A cross B? Earlier we discussed that, no? Cartesian product, what is the Cartesian product? Cartesian product.
Sir, 1, 2, 1, 2.
Yeah, 1, 2. So you can take this set A, if you write like that, set A is 1, 2, 3, 4. What is set B? Set B is 2, 4, 6, 8. Right? Then Cartesian product is, so it is by A cross B. A cross B is actually, so you take 1 into 2. 1, you take 1 with 2. Then 1 with 4. 1 with 4, 1 with 6, 1 with 8, like that, no? 1 with 6, 1 with 8. 1, then 2, 2, then you can take 2 with 2, 2 with 4, 2 with 6, 2 with 8, like that, no? 2, 4, 2, 6, 2, 8, 3, 2, 3, 4, 3, 6, 3, 8, 4, 2, 4, 4, 4, 6, 4, 8, like that. So this Cartesian product is a set, right? You know, cardinality of capital A is, what is the cardinality? Is 4. Number of elements of this set is known as cardinality. Sometimes it is denoted by Na, right? Most of the books, number of elements of a set Na is 4.
Cardinality is 4.
Cardinality is 4. Cardinality of B is also 4. Then what is the cardinality of A cross B? Right? 4 into 4, 16. You have 16 elements here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 elements. Right? Now actually this relation is subset of Cartesian product. So this is subset of A cross B.
What is 16, sir?
In Cartesian product, this A cross B has 16 elements. Right?
Yes, sir.
A cross B has 16 elements. Now R is subset of A cross B. Is it clear? Ultimately, if you take any subset of Cartesian product, that is the relation. Simply. So you can define another relation, right? So if you can define another relation, I will take that one R1. So R1, if you take like this, right? So this R, right? This relation denoted by R. Another relation, another two sets. So this set is, this is A, this is B. I will take another relation, 1, 3, 4. 2, 4, 6, 8, 6, 8. So A is mapped to 4. 2 also related to 4. 3 related to 6. 4 related to 6. Okay? And 1 is also related to 2. Okay? And 2 is also related to 6. Right. Now, this relation. Now, if you take this relation is R2, right? If you take that is R2, so R1, you take this is R1, then this relation is R1. R1, you can read it by 1, 2, 1, 4, 2, 4, 2, 6, 3, 6, 4, 6. So this is also subset of A cross B, no? This is also subset of A cross B. The R1 also, R1, R is a relation that is also subset of A cross B. R1 also relation that is also subset of A cross B. So what do you mean by that? Relation is actually subset of this Cartesian product. If you take any subset of this Cartesian product, that is a relation. Is it clear? Hello?
Sir, can you say it again, sir? Cartesian product?
Now this is clear now. You know how to get Cartesian product. We discussed
Yes, sir.
many
Yes.
times this one. Cartesian products, you know that. Now Cartesian product of this Cartesian product, you can get any subset. So that is a relation. Now you see this R is related to A. How this element A is related to 2. 2 is related to 2. 3 is related to 6. 4 is related to 6. So same relationship you can express like this, no? From this set.
Yes, sir.
Same pair of elements. Same.
So here you wrote R belongs to
1, 2. 1, 2 is this. 2, 2. 2, 2 is this. 3, 6. 3, 6 is this. 4, 8 is this.
yes, sir.
So it is a subset of A cross B. Right? But this 1, 2 is here. You see? 2, 2 is here. 2, 2 here. 3, 6 is here. 3, 6. 4, 8 is here. This 4, 8. Okay. So this R is a subset of A cross B. Is it clear?
Yes, sir.
Right. Then R1, I will take another relation. This is another relation, connected in different way. 1 is connected to 2, 1 is connected to 4, 2 is connected to 4, 2 is connected to 6, 3 is connected to 6, 4 is connected to 6. Right? Then same relationship you can express like this as a set. 1, 2, 1, 2, 1, 2. 1, 4, 1, 2. 2, 4, 2, 4. 2, 6, 2, 6. 3, 6, 3, 6. 4, 6, 4, 6. That's it. Yeah. But this is also subset of A cross B. You see, 1, 2 is here. This is 1, 2. 1, 4, 1, 4 is here. You see, 1, 4. Where is 1, 4?
Now understood, sir. Subset means it belongs to both of them.
1, 4. 2, 4 is here. 2, 4 is here. 2, 6 is here. Right? Like that, all these All these members are in A cross B. Therefore, these R1 also A cross B. Ultimately, what do you mean by that? That means if you take any subset from A cross B, that is a relation, right? That is a relation. Okay.
Yes.
If you take any subset, that is a relation. So you can take many subsets like that. Many subsets. How many subsets you can see? Using cardinal number of subset. Number of subset. How many subsets you can form using A cross B? So that's also we discussed earlier. How many subsets? Number of subsets. Number of subset of A cross B. Number of subsets A cross B is equal to 2 to the power of what? 2 to the power of cardinality of A cross B. That is 2 to the power of 16. Very big number. Very, very big amount of relation. Okay? Is it clear? Number of subsets. Earlier we discussed this is known as power set. Number of subset. Now power set is power set of A cross B. Power set of A cross B. Cardinality of power set of A cross B equals 2 to the power of 16. Cardinality. Number of subset of A cross B means cardinality of A cross B. Right? Okay. Right? Is it clear? Hello?
I wait, sir. Let me write it down.
Okay. Yes, this 2 to the power of 16 is total number of subsets. Right?
Okay.
Total number of subsets. So we discussed earlier uh, power set. How do you take power set? The number of subsets. How do you write down all all possible subsets? Right? Right? We discussed that, no? Now, if you take like this, now, likewise, you can write many relations A cross B, right? A cross B. So I will write another set like this, right? Can you tell me another relation on A cross from A to B? Write down another relation. Write down relation from A to B. Can you write another relation? Let's say you can take that relation is R2. How do you write R2? That means you have write any subset of A cross B. If you write any subset of A plus B, that's a relation. Okay. 1, 2, 1, 4, 1, 6, 3, 2, 3, 4, 4, 6, 4, 8. So this is subset of A plus B, A plus B. If you write any subset of A plus B, that is the relation. So this is the relation. Okay? Right? What is the cardinality of R2? 1, 2, 3, 4, 5, 6, 7. Cardinality of R2 is 7. Okay. Is it clear? Hello? Right?
Yes, sir.
Yeah. Now, regarding subsets, number of subsets is you have a problem, no? How to get the cardinality of a power set? Now, if you take A equals, I will take another symbol for this. I will take set X set X equals 0, 1, 2, 3, set Y equals 1, 3, 5. Right? Can you write what is power set? Now, first of all, you just write down all subsets X. Write down all subset of X. Write down all subset of X. Can you do it? Hello? Can you write down all subset of X? All subsets. All possible subsets. What do you write down? If you take this one, is this subset of X? 0 is subset of X or not?
No, sir.
Subset. It's a subset.
Subset.
Yes. If you take 1, this is a subset of X. This one, subset of X. This one, subset of X. This one, subset of X or not? This one? Yes, this is subset of X. This one, subset of X. This one, subset of X. All these are subsets of X. Null set, subset of X or no? Null set. Null set means set without any elements.
Yes, sir.
No?
Yes, it is also.
Yeah, it's a subset of X. So if you take, if you can select three elements. So you can take 1, 2, 3. So you discard the 0. Is this subset of X or not? Hello?
Yes.
Subset of X. If you take, then you can discard 1. 0, 2, 3. Subset of X. Then 0, 1, 3. Then you discard 2. If you drop the 2, you get this one. If you drop 0, you get this one. If you drop 1, you get this one. If you drop 2, you get this one. If you drop 3, 0, 1, 2. Right? These are subset of X.
Sir, how does
Because all these elements belongs to X. No? 0 belongs to X. 1 belongs to X. 2 belongs to X. Therefore, it's a subset of X. If you take entire set X, subset of X or no? Subset of X. X itself is a subset of X. Okay? These are the subsets. All these are subsets. Can you count the number of subsets? How many subsets? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, 16. No? 16. There are 16 subsets. There are 16 subsets. Okay. There are 16 subsets.
Yes, sir.
16 subsets. There are 16 subsets, number of subsets. So this also, if you take, you can take these are elements of the sets. That is known as what is the power px. Px. What is px? What is px? Px is all possible subset of x. So 5, 0, 1, 2,
Sir, all possible power.
all possible power set is power set includes all possible subsets. All subsets of x. 0, 2, 0, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3, 0, 2, 3, 0, 1, 3, 0, 1, 2, x. Okay. So this is the power set. Right? Power set consists of all the subsets of X. Power set X includes all What is the cardinality of power set? Can you tell me what is the cardinality of power set? What is the cardinality of power set? Hello?
Yes, sir.
What is the cardinality of power set?
Sir, after that you put x, sir. 0, 1, 2, then you put x.
Yeah, X is actually entire set. That is also subset of X. This one.
Why we put x?
Yeah, that is also subset. This is also subset.
Can we remove it?
Yeah, entire. No, not remove. 1, 0, 1, 2, 3. So this is X, no? Null set and total set. Entire set
okay.
also subset of X. Null set also subset of X. Entire set also subset of X. Okay? The entire set also includes in the power set, right? This X, phi and X, or phi and X belongs to Px. Huh? Phi belongs to Px, X also belongs to Px. Now, can you tell me what is the cardinality of Px? What is the cardinality? What is the cardinality of X? What is the cardinality of X? Hello? Hello, what is the cardinality of X?
16. Sorry.
X?
12. 12.
No. How do you say 12? I'm asking cardinality of X.
Cardinality of x, yes, sir. It's 4.
4, yes. What is the cardinality of Y?
The y is 3.
3. What is the cardinality of we didn't write Cartesian product here, right? We didn't get the Cartesian product, right? Because you want to you need that number of cardinality of power set now. Now we are discussing the cardinality of the power set now, right? Because you need that. So now tell me what is the cardinality of Px likewise. You just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16. Okay. Cardinality of Px is 16. Okay. So this equals 2 to the power of 4. What is 2 to the power of 4? So this is actually 2 to the power of cardinality of x. Cardinality of x is 4 or 2 to the power of 4. That's how you get. Cardinality of the power set is always 2 to the power of cardinality of x. Okay.
So this is Cartesian or cardinality? Are we finding here cardinality or Cartesian?
No, we didn't take Cartesian product for now, right? We just take the power set. Power set. The power set of x. Likewise, can you write what is the cardinality of can you write power set of y? What is the power set of y?
3.
Power set. Just write power set pi 1, 3, 5, 1, 3, 1, 5, 3, 5. Then y. So this is the cardinality of y. This is the power set y, power set of y. Power set of y includes the whole subset of y, set y. So this pi is subset of y. This also 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 subset of y. Why is this? Okay. This is the power. What is the cardinality? Cardinality of py is equal to cardinality is equal to 2 to the power of p. Why? Here p elements, 1, 2, 3. 2 to the power of 3. That is cardinality of y. Right? If you count 1, 2, 3, 4, 5, 6, 7, 8. Okay? 8. Okay. Hello? Is it clear?
Yes, sir.
Right. So power set includes all subset of that sets. Given set. So can you tell me what is the power set of if you take set like this? If you take so T equals A B O. This is T. What is the cardinality of PT? PT is the power set of T. Okay. What is the power cardinality? I will take like another two.
So this is another question, sir. D.
T is a set. It includes A, E, I, O, U. These are the. Then what is the cardinality of T? 2 to the power of 5. Okay. 32. Is it clear? Hmm. So if you write all the subset of T, you can write 32 subsets. Did you get it? Hmm? You can write 32 subsets. Very difficult, no? Hmm?
No. What five, sir?
5 is 1, 2, 3, 4, 5 elements. That's why 5.
Sir.
Right?
As cardinality, sir.
Identity of the power set. Power set of T is includes 32 subsets. So you can write the PT you can write actually. If you write PT, it includes null sets, then sets having single elements A, E, I, O, U. Then you can take 2 by 2, no? A, E, A, O. Like that you can write all subset. When you fill this sets, you can fill you will get 32 subsets. 32 subsets. Is it clear? Hmm? Okay. Finally, T also includes that. Last one is T. Okay. Is it clear?
Yes, sir.
Right. So what is the power set of Cartier product? So I will take this same pair of sets again. Now you can define. I will take this one. Uh, Now if you take X, how do you write Cartesian product of this? X how do you write A cross B? A cross, sorry, A cross Y, sorry, not A cross B, A cross, X cross Y. How do you write X cross? Cartesian product of X and Y. 0, 1, 0, 3, 0, 5, 1, 1, 1, 3, 1, 5, 2, 1, 2, 3, 2, 5, 3, 1, 3, 3, 3, 5. Okay? Cartesian products. Now this is a set. X cross Y is a set. Then for this also you can write down the power set. Right? For this set you can write power sets. Power set includes all subsets. Right? What is subset? Subset is a relation. Is it clear? If you take any subset of X cross Y, it is a relation. Right? Then can you tell me how many relations are there from X to Y? How many relations? How many relations are there from X to Y? How many?
Sir, sir, before you took
So this is a Cartesian product. If you take any subset of this Cartesian product, it's a relation. Then how many relations are there from X to Y?
sir, you mean these are called relations? Sir, what is X and Y? I mean these digits. What are they called?
This X, right?
No, sir, what are these called?
This Y. So
No,
this
sir,
Cartesian product, right? We discussed this one many times.
yes, sir. Cartesian product.
Yeah, this is a Cartesian product, X plus Y. I am asking, can you tell me at least one relation? Hmm? One relation. Let's say R1. Hmm? How do you? Can you write? Hmm? So if you take any subset of X plus Y, it's a relation. 1, 0, 1. 0, 5. So this is
Sir, can you say here you put bracket, but not curly bracket, right? Sir?
curly brackets always used for set, no? Right? So this is not a set. 0, 1. If you don't put curly brackets, so this is not a set. If you put like this, the curly brackets like this is a set. Two different things. So if you use normal brackets, right? If you use curly bracket with comma like this, that means this is a set with two elements. This has two members. But this is just a member, not a set. Okay. Is it clear?
Yes, sir.
Right? So carefully you have to take it. Now 0, 1 is a two tuples. This is not a set. Sets, and if you use a set, so you have to use curly brackets. Now you see this one. If you took like again, you look at this. Now here, all these are curly brackets. See, these are curly brackets. Therefore, each of these are sets. This also set. All these are curly brackets. Right? Here also curly brackets. Right? So it's a set. Those are sets. Right? If you take previous one like that, you see these are sets. All these are sets. Right? But these are not sets. But this entire thing is sets. R2 is a set, but this 1, 2 is not a set. This is not a set, right? Okay? That's the element of R2. One member of R2, right? This member of R2. This is also member of R2, right? These are not curly brackets, no? Therefore, 2, 3 is one element of R2 or member. Okay? The X is capital X is a set, capital Y is a set. Is it okay? Hello? Now, if you take this is a Cartesian product, X cross Y. So R1, if you take two elements, this is a relation. You can write another relation R2 0 3 0 5 1 1 1 3 1 5. So this is R2. If you write R3 0 1 3 5. Is sorry, not curly brackets, right? It's normal bracket. If you use curly brackets, then wrong, eh? R4, what is R4? R4 1 1 1 3. Okay? R5 null set. R6 X cross Y. If you take X cross Y, if you take entire set also, it is a relation of X cross Y. Okay? So you can write down many relations. How many relations you can write? Total number of relations. Right? So you can write 2 to the power of 12 relations. How did I get this 12? Here you have, out of this number, you have only 1, 2, 3, 4, 5, 6 relations. But you can write 2 to the power of 12 relations. Total number of relations. 2 to the power of 12. How did I pick up this 12? Can you tell me? From where did I pick up this 12? Hello?
Yes, sir, because 3, 4.
3 into 4, 12, yes.
Yes.
Or you can count these elements of this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? That is the cardinality of 2 to the cardinality of X cross Y. Cardinality of X cross Y. cardinality of x plus y equals cardinality x into cardinality of y, right? That is how you get to the number of relations, all total number of relations, right? Null set also includes, that is known as null relation, right? Entire set also you can consider as a relation, that is also entire relation. Okay, is it clear?
Yes, sir.
Let uh, P, P is a set. Normally we use P for power set now, so we can use different symbol. Shall I take D? The set D, D includes 1, 2, 3, 4, 5. And can you write down a relation? Can you write down D cross D, Cartesian product D cross D? Previously we wrote Cartesian product A cross B, and X cross Y. Now you can write the Cartesian product within a single set from D set D from D from the set D to itself. That relation is from D to itself. Okay. Uh, then what is the Cartesian product? D equals 1, 2, 3, 4. So you can match, 1 is match to 1. 1, 2, 1, 3, 1, 4, like that. You can write many 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 5, 1, 5, 2, 5, 3, 5, 2, 5, 5. Okay. Is it clear? Then D cross D. So you can write down like that. D cross D. So can you write down relation? So normally relation from D to D, right, is written as relation on D. Simply you write like that, relation on D. Is it clear? Because you have single set, no? Relation on D. Can you tell me one relation R1? If you take relations as letter F1, I will take different letters. Relation F1. How do you write F1 relation? 1, 1. So this single element. F2, 1, 3, 1, 5. F3, 4, 4, 4, 4. 5, 1, 5, 2. Like that. So you can write many relations. These are relations. So you can write many relations. So F1 is relation on D, F2 also relation on D, F3 also a relation on D. Normally you don't say from D to D. Relation from D to D.
So why F1 like this? Yeah? Why not R1, R2, R3?
Yeah, you can use any symbol. No need to use always R. You just use the other symbol. And you can, but you have to. So this is a relation. F1 is a relation. F2 is a relation. Normally, if letter F used for functions, still we didn't discuss for functions. So you can use for relations. Letter F you can use relations for relations also, right? Function also relation. But these are not functions. Function has special properties. Function also relations having some special properties. Right? Okay.
Yes.
Then I think you understood relation on. Now relation on if one say
So why
relation.
we took separately F3? We can take more of F3 or no?
Yes. No. What did you say?
You stop till F3. We can take F4, F5.
For this one, so say D.
No, sir. F1, F2, F3. We can take F4.
Not only F3, you can write F4, you can write F5, you can write. How many? How many relations can you write? You know now that. Up to F. So D cross D includes here total number of here 5 by 25. F F2 to the power of 25. F2 to the power of 25 you can write. Very big number. 2 to the power of 25 is very big number.
Yes, sir.
Right? So this much relations you can write. That is 2 to the power of 25 relations. How many relations? So what is 2 to the power of 25? Can you find it? 2 to the power of 25. What is that number? 355.
No, sir. Double 3, double 5, double 4.
This much.
Then 3, 2. Sure, again, 3, 2.
3, 2. Right. Okay, this much. Very big number.
Yes, sir.
Right. So when you write this much of relations, so you need very big space. But we wrote only 3 relations out of this much relations. Okay. Hmm. For these relations, what is the parent set? Parent set is D. D is the parent set, right? These relations originated from D. First you take D cross D. From D cross D, you have chosen subsets. Those subsets are relations. Okay? Then parent set is D. Right? But D has only 5 elements. Due to these 5 elements, from these 5 elements, how many relations you can build up? This much relations. Very big now. Right? If you, instead of D, if you take infinite subset, infinite sets,
Yes, sir.
then how big is the number of relations?
So infinite relation.
Yeah, infinitely many relations. You can write infinitely many relations. Okay? If the parent set is infinite sets, for example, can you tell me, instead of this D, if you choose D equals, instead of D, if you take Z as the parent set of integers, if you take set of integers as parent sets, those relations you can define like that. Let's say if X is related to Y, if X is related to Y, if X minus Y is divisible by 3. So this is relation, right? X minus Y is divisible by 3. Right? So how do you define this relation? So R equals XY X Y belongs to say, and X minus Y is divisible by 3. Okay. What is the cardinality of R? What is the cardinality of R? What is cardinality of Z? Hello? What is the cardinality of R? What is the cardinality of Z? Hello? Cardinality of Z, this infinite set, number of integers is infinite. Therefore, this is also infinite. Hmm? There are many elements to R. Not because of this, R is really this infinite because you cannot never list out the elements of this R. Right? Can you list out few elements of R? Is it possible to list out few elements of R? If I ask 2, 1 belongs to R, is this 2? 2, 1 belongs to R or 2, 1 not belongs to R? Hello? 2, 1 belongs to R or 2, 1 not belongs to R? Hello? Now here R is subset of Z cross Z. R is subset of Z cross Z. Hello?
Sir, I'm not understanding.
Now, Z is, you just think that Z is a set, right? Then you can take Z cross Z. Now, imagine Z actually not a finite set. If Z is infinite set, suppose Z is finite set, then you can imagine what you mean by Z cross Z, no? Okay?
So Z infinite means Z cross Z?
Z cross Z is also infinite. You can never list out the members of Z cross Z. All members of Z cross Z. Because it is infinite set, no? Right? It's an infinite set. So Z is a set of integers. It is infinite set. Suppose if it is suppose Z is a finite set like the set D previously considered set. If you take set capital D, so if you take this set is this one, D is finite set, no? Yeah. Right? D cross D, all possible two tuples you can list out. That means you can list out all the elements of D cross D. But here it is infinite set. Z is infinite set. Can you list out Z cross Z? Is it possible to list out? Can't. Because Z is an infinite set, therefore Z cross Z is also infinite set. So can you list out these R, elements of R? You can never list out. But if you want, you can write down only few elements. Right? Suppose if you are given the elements, you can check it is belongs to R or not. If someone given, let's now I am giving this 2, 1. I am asking 2, 1. 2, 1 belongs to R or 2, 1 does not belong to R. 2, 1 belongs to R or 2, 1 does not belong to R. Can you tell me?
So how can I tell you, sir? Because 2 is also infinity.
So this first number is x value, right? This is x, this y. Now x minus 2 minus 1 is not divisible by 3. 2 minus 1 is 1. 1 is not divisible by 3, then you can't take x does not belong to R. Okay? 2, 1 does not belong to R. Okay. But if you take 1, 4 belongs to R or not? Actually 1 minus 4 equals minus 3. Minus 3 is divisible by 3. Therefore 1, 4 belongs to R. This is correct. Okay? Right. 5, 8 belongs to R or not? Yes. 5 minus 8 is minus 3. Minus 3 is divisible by 3, therefore 5, 8 is belongs to R. Okay? Hmm? Then 24, 3. 24 minus 3 is belongs 21. 21 is divisible by 3. So therefore 24, 3 belongs to R. Okay. Hmm. So if I take 10,000 and 10,000 10,003 belongs to R or not? So this element belongs to R. Why? If you take this difference, it's minus 3. Minus 3 is divisible by 3. Therefore, it belongs to R. Hmm? Is it clear?
Sir, 1000 also 1000 belongs to R.
1,000, 10,000 and 10,003 belongs to R. 10,000,
1000.
yeah. This element belongs to R.
1000.
Hmm? There should be another zero, no? No. 0, 0 here, 10,000, here 10,003. Hmm? Okay, belongs to R. Right? So you can write many relations like that. So you can show this relation is the properties of relation you can discuss. What are the properties of relation? Hmm? Reflexive, reflexive property, symmetric property, and transitive property. What is reflexive property? Reflexive properties for all A belongs to Z. Hmm? If A belongs to R, right? So for all A belongs to Z, A belongs to R, then we say it is a reflexive. Hmm?
Yes, sir.
Reflexive relationship. Hmm? The symmetric means if if AB belongs to R implies BA also belongs to R, then symmetry. This is symmetry. If AB belongs to R, then BA also belongs to R. Then it is symmetry. Okay. Transitive. Hmm? If AB belongs to R and BC belongs to R, implies AC belongs to R. So this is transitive property. If all these three properties are true for given relationship, that relationship known as equivalent relationship. Equivalent relation. Right? The relation we discussed, this one is equivalent relation. You can show this equivalent relation. Right? Because all these three properties are true for this relation. Right? So our parent set is the R. So R is relation on the set, and it is defined by defined by x minus y is divisible by 5. Right? Relation on R. That means relation on from Z to Z. Or it's a subset of Z cross Z. Right? So that R is an equivalent relation. Equivalent relation. First you have the reflexive property. Check whether reflexive property is true. Reflexive property, let A belongs to Z. Now if A belongs to Z means A is an integer. A is an integer. Then what is A minus A? A minus A is equal to 0. That means A minus A is divisible by 0 is divisible by any number, divisible by 5. Therefore, A belongs to R. Therefore, R is reflexive. Okay? Then R is reflexive. Is it clear?
Yes, sir.
Then you check whether this relation is reflexive, then symmetric.
So A minus A is equal to 0, sir. How it should be 0?
Because our relation is this one. Our relation is R equals xy. So you can write in formal way xy, then xy belongs to integer set and x minus y equals is divisible by by 5. So these are relations. Right? Now a minus a is 0, no? 0 is divisible by 5. Therefore a belongs to R. So actually you are, that means 1, if you take 1 belongs to R. 2 belongs to R. 3 belongs to R. 4 belongs to R. -1 belongs to R. 0 belongs to R. Okay. All these elements belongs to R. Right? All the elements of this form belongs to R, included in this relation. Right? Therefore R is reflexive. Right? Symmetric. Symmetric means suppose AB belongs to R. Suppose AB belongs to R. Then A minus B is divisible by 5. If A minus B is divisible by 5, then B minus A also divisible by 5. Then B minus A is also divisible by 5. Therefore, BA belongs to R. Therefore, R is symmetric. Okay? R is symmetric. Right?
Yes, sir.
Now last property, third property is transitive property. Next we can take transitive property. Transitive property you can take, let AB belongs to R and BC belongs to R. AB belongs to R, BC belongs to R, then what can you say? Then if AB belongs to R means A minus B is divisible by 5. That is A minus B equals 5K1. Okay? So this is why. Where K1 belongs to Z. K1 is an integer, otherwise you can say it is divisible by 5. If it is divisible by 5, then A minus B is multiple of 5. Right?
Yes, sir.
So you can write it as A minus B equals 5 times certain integer, right? Then BC belongs to R means R, that means B minus C is divisible by 5. That means B minus C equals 5K2. This is 2, equation 2, where K2 belongs to, K2 is an integer, right? K2 is an integer. Okay. Now you can add 1 plus 2. Just add by 1 plus 2. If you add 1 plus 2, minus b plus b get cancelled. Left hand side you will get a minus c. Right hand side you can take 5 out, k1 plus k2. But k1 plus k2 is also an integer. This is also an integer. Integer. Right? So it equals 5k. Right? Where k belongs to shell. Because k1 is an integer, k2 also integer, then k1 plus k2 also integer. Okay. This means AC is A minus C is divisible by A minus C. A minus C is divisible by 5. Therefore, AC belongs to R. Now if you have in that relation AB belongs to R and BC belongs to R, then you can show AC belongs to R, right? Therefore, this relation is transitive. The relation is transitive, right? The relation is, therefore, the relation transitive. Therefore, for this R, reflexive property, symmetric property, and transitive property, all these three properties are true, right? Therefore, the R is an equivalent relation. Therefore, R is an equivalent relation. Equivalent relation. Okay. Is it clear?
So, can you explain from this part, sir?
Which part?
From this part.
This one.
So, yes, sir. BC belongs to R. Okay.
AB belongs to R. That means A minus B is divisible by pi. No?
Yes, sir.
Otherwise, AB not belongs to R. If AB is divisible by pi only, AB belongs to R. Now, if you take AB belongs to R, then A minus B is divisible by pi. So, A minus B is multiple of pi. Pi k1,
Yes.
where k1 is an integer. Right? If BC
Yes.
belongs to R, same way, B minus C is divisible by pi. Then B minus C is a multiple of pi. Therefore, you can write pi k2. Now you add these 1 and 2 equations.
Then we will add.
Minus B plus B get cancelled. Minus B plus B get cancelled. We only remain A minus C. A, here minus C, A minus C. Right hand side you can take 5 out. 5 times k1 plus k2. is 5k. Right? K1 plus K2 also an integer because K1 also integer, K2 also integer. Sum of two integers also integer. Therefore, it's 5k. Now you have A minus C is divisible by 5. Therefore, AC belongs to R. Now, when you take AB belongs to R, BC belongs to R, then AC also belongs to R. Therefore, it is transitive. Relation is transitive. Relation transitive means relation. Now, this relation has all three properties. Therefore, R is an equivalent relation. Okay? Is it clear? Hello?
Yes, sir. So